Don't panic. You've been abducted by alien AI, and they're not here to be your friends. Just your luck, right? Why couldn't this happen to someone else? Like Mean Girl Madison. God, she's the worst. But it's no time to mess around. The AI aren't ruthless, just picky. They only respect intelligent life, and to be honest, they're not sure you qualify. Even if they could speak English, I don't think the AI want to hear your top 10 list of anime betrayals. Unfortunately, that means you'll need to use the universal language, math. That's right, your old friend, mathematics. I know what you're thinking. Why didn't I pay more attention in math class? Well, let's not dwell on the past, so we can focus on you not getting obliterated by a freaking death laser. Long story short, you're going to have to prove something to them. No, not the fundamental theorem of calculus. The Pythagorean Theorem. But first, you'll need to know a little bit about those three-sided doohickeys. Triangles.
Jen.
3 sides form a triangle. Well, sometimes. Other times, the sides don't touch. You know, like when you can't reach the corn blast that they put on the top shelf just to spite you. If the 2 shorter sides combined aren't longer than the third, you can't even form a triangle. In order for all 3 sides to touch, the 2 shorter ones together must be greater than the third. That's the triangle inequality. Yes, it's a bit of a mouthful, but it is an inequality about triangles. Once you pick the side lengths and draw your triangle, we need to switch gears. Ironically, the Pythagorean theorem, which is famous for triangles, is really about the areas of these squares. And for that, we'll need multiplication. Multiplication and area are really 2 sides of the same coin. 3 times 4 means 4 plus 4 plus 4. Or, in other words, 3 equal groups of 4. Since we can count pretty much anything, let's count squares so we can easily arrange them into a rectangle. This rectangle will be 4 wide and 3 tall, which is an area of 12. And again, rectangles and multiplication, one and the same. Similarly, you can represent 5 times 5 with this rectangle, a square. Anytime you multiply a number by itself, the rectangle is always a square, including whatever number a is. A times a is a squared. Oh, so that's why they call it a squared, because it's a square. I knew that. So if a triangle has side lengths of a, b, and c, the squares have areas of a squared, b squared, and c squared. But what is the relationship between these areas? It might help to think of the squares around the triangle as sandboxes. At first glance, there appears to be no obvious connection between their areas. The amount of sand, or area, in the 2 smaller boxes isn't required to be the same as the larger one. It's quite possible for these 2 combined areas to be much less or much more than the third. And it stands to reason that somewhere in between it must be just right. The AI, in their infinite glorious wisdom, please don't hurt me, can predict exactly when these areas will be the same. If you can convince them that you can too, well, you just might live to tell the tale. Billy over here thought the Pythagorean theorem was true for all triangles. Silly Billy. Let's take a look at a few more triangles so we don't end up like Billy. This triangle has side lengths of 4, 5, and 6. That gives us 16, 25, and 36 for the areas of the squares. The total area of the 2 smaller squares is 41, which is larger than the third. Too much. This one has side lengths of 3, 3, and 5, which gives 9, 9, and 25. Here, these add up to only 18, which is less than the third. Too little. On the other hand, the smaller squares in this 3, 4, 5 triangle add up to exactly 25. Just right. Let's try a few more triangles. These, too much. And these, too little. But this one, it's just right. Notice anything about the triangles in each group? When it was too much, the bigger squares made taller triangles. We call them acute. When it was too little, the triangles had to be flatter. Those are obtuse. And these triangles that are just right are called, well, right triangles. The triangles that are right always produce exactly equal areas. Pretty simple, huh? Right triangles have 3 sides. Duh. two shorter sides called legs, and a longer side called the hypotenuse. Hypotenuse? Hypotenuse. The sum of the smaller squares is the same as the hypotenuse square. This is called the Pythagorean Theorem. Not just a quirky relationship of the squares around a right triangle, but a method of calculating the distances between points, the basis of trigonometry and therefore architecture, as well as the foundation of practically all of physics. Almost every single aspect of modern society, from phones to buildings to microwaves, hinge on this fact. So it's no wonder these AI decided to use it to weed out the riffraff. Still skeptical? How do we know that the smaller squares will always be exactly the same size as the larger one? Imagine getting a burger from your favorite burger joint, but the cook's too distracted with existential dread to put the cheese on straight. And being mildly OCD, as we all can be, you really couldn't stomach this patty travesty, so you surgically remove and replace the cheddar overhang to fit precisely on the bare burger bits. In much the same way, we can cover the hypotenuse square perfectly using pieces of the two smaller ones. That means these smaller squares exactly equal the hypotenuse square. Do you see how each piece that's uncovered matches with a corresponding piece that's missing? The matching pieces remain the same even as the side lengths change. It works no matter how big the sides of the triangle are, as long as it's right. This is just the thing you need to convince the AI that you have more than two brain cells to rub together. Okay, it's showtime. Don't forget, this is the Pythagorean Theorem, and it promises that for any right triangle, the squares of the smaller sides add up to the larger one. You got this. Do humanity proud. Or don't, it's your funeral.